Okay, this video is on Venn diagrams, sets, unions, and intersections, and I got a lot to cover, so I'm going to get right into this. You should be on page 71, and we're going to go over some vocabulary first. Let's talk about a set first. A set is a collection of objects. I want to give an example, a non-math example, to help you wrap your mind around this as best as possible. I'm going to use baseball cards. A set would be a collection of objects. So I'm going to say, like, I have a set of Detroit Tiger baseball cards. The cards I have would be the set. It's a collection of objects in that set, all right? So that's simply what a set is. It's a collection of objects. You could think of stamp collecting. You have a set of stamps. It could be coins. Those things are sets. The objects, you have a set of something, a set of objects. That's what a set is. An element is a member of the set. If I go back to my Detroit Tiger baseball card collection, my Prince Fielder card is an element of that set. It's a member of the set. Mathematically, an example of a set could be a group of numbers like 2, 3, 4, 5, 6, 7. Okay, so let's say that those are the elements of my set. Each one of these members are an element. So I have a set of numbers. Each one of these are an element. Sometimes, to make it easy, we don't call our set, like here, I have a set of numbers 2, 3, 4, 5, 6. Just to make it easy, I might give it a name like set A. So when I say set A, I'm talking about the numbers 2, 3, 4, 5, 6, 7. And when I write set A out, it's nice to use set notation. Set notation means to write all the elements of your set inside of braces. These little symbols here are braces. So I could write set A in this manner. A equals braces 2, 3, 4, 5, 6, 7, close braces. This is how I can write properly on paper set A, which I said was these elements, in set notation. So far we've talked about a set, element, and set notation and what that looks like. There are two special kinds of sets. One would be an empty set, which means you have nothing in it. Now you might wonder when would that happen? Well, again, go back to my baseball card collection. My Detroit Tiger card collection, I got a lot of those. Got a lot of players in that collection. Well, let's say I just decide to start a New York Yankee baseball card set, and I don't have any Yankee cards yet. Right now, I have an empty set for my Yankee card collection. Okay, empty set. Another special set is called the universal set. And universal set, first of all, the symbol for it looks like a horseshoe. And universal set means you have all the elements in it. So maybe my Detroit Tiger card collection, I have every card possible for this year's Detroit Tiger players. I have every one of them. I'm not missing any of them. It's a universal set. I have all the possible cards in that collection. A union of sets is combining both sets together. A U is the symbol for a union. It's simply just combining all the sets together, or all the elements of each set together. All right. Where an intersection of sets, first of all, the symbol for that is an upside down U. An intersection of sets is we're just combining the elements that both sets have in common together. Now, sometimes my students struggle with the difference between union and intersection, so what I wanted to do is just do a non-math example of union and intersection. So let's do that. I'll do it on my next slide here. Here's, I think, a simple example that you'll fully understand. Let's say I have a student, Julia, in my room, and Julia has pencil, paper, and ruler. That's what she brought to class, pencil, paper, and ruler. And sitting next to her is Nathan, and Nathan has a pencil, pen, and calculator with him. And so I tell them to combine, put their desks together and sit together, and I ask them to take a union of the elements of their sets. Well, Julia's elements are pencil, paper, ruler. Nathan, his set of elements are pencil, pen, calculator. Well, union is just combining everything they have together. So when we do that, When we combine everything they have together, that's what a union is, they now combined have a pencil, paper, ruler, pen, and calculator. That's what a union is. However, if I ask them to intersect what they have, I'm asking them, what do you both have in common? Just group what you have in common together. Well, if you look, the only thing that both of them right now have in common is right here. They both have a pencil. They don't have anything else in common. The intersection is what do they have in common. They have a pencil in common, and that's it. That's the difference between union and intersection. Union is combining everything. Intersection is just what do you have in common. If you go to page 72, we'll practice some problems with union, intersection, and set notation with numbers. So if you go to problem 1, we'll do a sample. It says, let U, I wish they would have used a different letter. I wish they would have used, like, let's say, let R be the, well, I don't know if I like R either. Let's say use X. X is the set of whole numbers from 0 to 10. We'll say that instead of U. And the only reason I don't like U is because it says let A union B. We don't want to confuse union with a set. Let A union B, and we want to find A intersect B for the specified sets A and B. So again, if I said let X be the set of whole numbers, so we're saying X is all the numbers from 0 to 10. That's the only possible numbers out there. And we're going to take the set A, which you see in number 1. Set A is 1, 3, 5, 7, 9. And set B is 3, 6, 9. And I want to unite those sets together. Uniting means just combine everything together. So let's combine them all together. Well, if I combine everything together, we now have a 1, 3, 5, 6, 7, and 9 all together. That's if I unite A and B all together. What if I intersect set A and B? That's telling me take what does A and B have in common and make a set out of it. Well, what do they have in common? I'm looking carefully. They both have a 3 and they both have a 9, and that's it. So there we go in set notation. Remember, when we write these out, we use braces. You always write unions and intersections in set notation. If you go to number 4, they're just having us practice writing range and functions in set notation. The directions say, consider the specified function and domain. Write the range and function using set notation. Well, we wrote ranges and things like that in chapter 1. Domain, range, here's a function. We've inputted the domain. The range was the output. We wrote a table. Easy stuff. I'm asking you to do the same thing here. I just want it written in set notation. So first of all, here's my domain in set notation. These are my inputs. Let's get the range. So if I input 1, 2 times 1 is 2, we output 2. If I input 2, we output 4. If we input 3, 2 times 3 is 6, we output 6. If we input 4, this outputs 8. And if we input 5, this outputs 10. So if my domain is 1, 2, 3, 4, 5, my range is going to be 2, 4, 6, 8, 10. And I wrote it in set notation. Now they want me to write my function in set notation. Now I always had you write your functions using a table in chapter 1. And you can see that if I input 1, we got 2. If we inputted 2, we outputted 4, etc. Instead of writing a table, which I think you're familiar with, we just want to write this in set notation, which would look like this. It'd be braces. And instead of writing 1, 2 in a table, we'll just put braces. Here's the ordered pair 1, 2. Followed by, here's the ordered pair 2, 4. Followed by, we would have had 3, 6 next. Followed by 4, 8, and 5, 10. That's set notation for writing a function. Next, we want to talk about Venn diagrams and how we use those and why they're important. First of all, Venn diagrams are a visual of intersections and unions. So basically, we're going to do some basic things first, understanding what that looks like, what intersections and unions look like on a Venn diagram and where they are at. So let's take a set A and a set B, and we want to intersect these things. Remember, everything in this circle is part of set A. Everything in this circle is part of set B. I want to combine what they have together. I want to intersect them. Well, I think it's easy to see here that the only things that are part of both sets are in here. So the proper shading for this, the proper diagram for A intersecting with B would be here. These are the elements in here that are part of both A and B at the same time. Let's talk about A union B. Now, A union B means I want to combine everything in set A with everything in set B. Well, if I unite everything together, that means all of these things are now in this new combined united set. Well, that means everything. This would be a correct picture of A union B. So now I get into this. I have three sets that I'm going to look at how they unite and intersect. So I have A intersecting the union of B and C. Let's start here. Union B and C. Now I'm going to use a highlighter, and what I'm going to highlight, pretend I'm not actually drawing this highlight on paper, I'm just thinking this in my mind. So what I'm going to draw here is not actually happening on paper, I'm just picturing it in my mind. Let's picture B union C in our mind. So I don't even care about circle A. If I could cross this out, if it wasn't even there, it'd be good right now, but it's there, so don't worry about it. But we're going to do B union C. Well, doesn't B union C mean that everything in circle B and everything in circle C get combined together? Okay, so in my mind, I'm picturing, I'll do it in light blue, everything in B and everything in C are combined together. That's what B union C means. Now what I want to do is I want to take that and intersect it with A. In other words, what does B union C have in common with A? Well, let's take a look. Now remember, the light blue is just in my mind. I didn't actually draw it on paper. Here's where B union C and A are in common. They're in common here, here, and here. That's the only places where circle A is in common or intersecting B union C. So the correct shading, now I'm going to actually take my pencil out, the correct shading would be here, here, and here. Now remember, the light blue I just did in my head, so maybe I can just erase it out. The light blue is not supposed to be part of this, so I'm just going to get rid of that. That was just what I was imagining in my head. Okay, so the proper answer on paper is what I just shaded in black. So the correct drawing for A intersecting B union C would just be here, what I've shaded in black only. Okay, what I did in blue was just what I was thinking in my mind. Let's do one more. Let's try this one. We have A intersecting B intersecting C. So I start here. A intersect B. Let's just do that in our head. I'll get out my little marker again. Where is A intersecting B? Well, where is A and B in common? Only here in this part. This is where A and B are in common. All I care about is circle A and B right now. I don't even care about circle C. This is where A and B are in common. I want to take that and intersect it with C. So in my mind, I was thinking in light blue, okay, here's A intersecting B. What does this have in common with circle C? Well, the only place circle C is in common with this A intersecting B would be this little part right here. So remember, what I did in light blue is just what I was mentally thinking. It wasn't actually on paper. What I would actually draw on paper is just this. In fact, I'll get rid of that, what I was thinking in my head. That's not actually part of A intersect B intersect C. It's just the part in dark. So now, why do we use Venn diagrams? And I should have erased this, and I didn't, and I want to, let me get rid of what I have here. Looks like I practiced this and forgot to erase something, so just give me a second to get rid of these. Okay, so here's what I wanted. This is what this picture is about. Here's me in my classroom, and pretend my classroom, I have 12 students, and my 12 students are represented, as you can see, with desks. I have 12 desks. So I'm in my classroom sitting here all by myself, and there's 12 students in here. And here's what I ask my students. I ask them, first of all, I ask them, raise your hand if you're wearing green today. And these students that I'm putting an X at their desk happen to raise their hand. And you notice, as I count here, I have 1, 2, 3, 4, 5, 6, 7, 8 students that just raised their hand. Yes, Mr. Lemansky, I'm wearing green. Okay, now I ask the same kids the second question. I'm like, okay, everybody, now I want you to raise your hand if you're wearing blue. And these students all raised their hand. These are the students that were wearing blue today. And you notice we had 1, 2, 3, 4, 5, 6, 7 wearing blue. Okay, now you weren't in the room. You didn't get to see this. And so now I walk out in the hallway and I'm talking to you and I said, okay, I just was in my room and I asked my kids how many are wearing green and 8 raised their hand. And I asked them how many are wearing blue and 7 raised their hand. And then I asked you, how many kids do you think are in my room? The number one answer people are going to give me is they're just going to say 8 plus 7 is 15. Well, there must have been 15 kids in your room, which obviously is wrong. You can see that from this picture. Well, here's what the mistake is. When you say 8 plus 7 is 15, we did not consider that some people were raising their hand 2 different times. Okay? That's what a Venn diagram helps us eliminate, I guess you could say, or helps us eliminate mistakes on when we have word problems. It helps us eliminate mistakes like that where there's overlap. So, I'm going to give you this worksheet tomorrow. We're going to work through a couple of these together so you can understand how you can draw a Venn diagram to help you out with problems such as this one here. So let's read it first. Out of 40 students, 14 are taking English composition, 29 are taking chemistry. If 5 students are in both classes, how many students are in neither class? How many are in either class? What is the probability that a randomly chosen student from this group is taking only chemistry class? Okay, so there's a ton of information there. We need to break this down, or you might be like, holy smokes, I'm overwhelmed already. I can't do it. All right, so let's start here. We start off, there are 40 students. So the first thing you do, and you can see that I did it here, you draw a large box. And you put a 40 outside of it. That means inside this box there are 40 students. Second thing, we have people taking English and chemistry. I'm going to draw a circle for English. This circle, inside this circle is all the English students. I'm going to draw a second circle for chemistry. Inside this circle is all the students for chemistry. Now you notice we had 14 students taking English, so I put a 14 out here. Okay, here's what that means. It means if I add up these students and these students, now you notice the 2 parts of the circle, these 2 have to add up to 14. There's 14 students in this circle. I'll put a 29 outside the chemistry circle. There are 29 kids in chemistry. You notice these kids take chemistry, so do these kids. These 2 must add up to 29. I put a little line up here. These are the students that are part of the 40 that didn't take either class. They're not taking English and they're not taking chemistry. Okay, so let's keep on going. If 5 students are in both classes, these are the students right here in both classes. I'll put a 5 there. If 5 students are in both classes, how many are in neither? Okay, we get to all these questions. Well, before we answer the questions, let's fill out the rest of this picture now, okay? We knew there's 40 students outside this, 40 students in the class, so I put a 40 outside the box. Well, if there's 5 students doing both, now remember, these 5 students are taking English, 5 plus what is 14? Well, 5 plus 9. Remember, these 2 have to add up to 14. Chemistry. There's 29 students in that class. Well, there's 5 over here that are part of chemistry class that are taking English. 5 plus what is 29? Well, it's right here, 24. Okay, here's what this picture tells me so far. Can you see the 14 taking English? This is telling me that 9 of those 14 only take English. They're not also taking chemistry. 5 took English and chemistry, but you see there's still 14 kids taking English. This is telling me that 24 students just took chemistry. There were 5 others that took chemistry that took English. There's my 29 chemistry students. Okay, now remember, if you add this, and this up, I'm supposed to get 40. Well, now I can find out what this number is. 25, I'm sorry, I misspoke. 24, I meant to say, plus 5 is 29. 29 plus 9 is 38. 38 plus blank is 40. This must be 2. Well, now I have all the information I need to answer all the questions above. Remember that we had 40 people in here. Let's answer the questions. How many students are in neither class? Well, it's right here, 2. How many are in either class? Well, if I, out of the 40 students, if I said, okay, who's taking English or chemistry? Well, these people would raise their hand. So would these people. They're taking English or chemistry. They're taking one of the 2 at least. So are these people. 24, 5, and 9. There's 38 taking either class. What is the probability that a randomly chosen student from this group is only in chemistry? Well, what people in here are only taking chemistry? Well, they're right here. There's 24 only taking chemistry out of how many altogether? Well, remember, we had 40 altogether. 24 40ths would be the probability that someone is just taking chemistry. That's what a Venn diagram is for. It helps us when we have a problem with overlap, which this certainly does. Got a couple more examples. I'm going to work a couple off the worksheet with you that I'm going to hand out tomorrow. So let's do this one. In a class of 50 students, let's stop there first. Here's my whole class. And inside here, I have 50 students. So I'll put a 50 out here. 18 take chorus. Well, here's my chorus circle. There's 18 in there. 26 take band. Okay, there's my band circle. Well, I guess I can call it a circle. Pretty crummy circle, but I think you get the idea. Okay, 18 are in the chorus circle. That means if I add these 2 up, these people are both in the chorus circle, I got to get 18. 26 take band. That means these 2 have to add up to 26. 2 take both. Well, what people in here end up with both? Well, right in here. These are the people that do both, right here, just in this part. You can see they're part of chorus and band. Okay, before I answer the question, let's fill out the rest of this. Well, if this is 2, 2 plus what's 18? Well, 2 plus 16 is 18. 2 plus what's 26? Well, that's got to be a 24. If I add this, and this together, I got to get 50. Well, let's check. 24 and 16 over here gives me 40. 40 plus 2 is 42, and 42 plus that's 50. That's got to be 8. Here's the question. How many students in the class are not enrolled in either chorus or band? Well, these 8 are going to raise their hand. They're not part of either. Answer's 8. I think you can see how that works now. Here's a little bit tougher one. It says a veterinarian surveys 26 of his patrons. So we have a group here of 26 that are taking a survey. So there's 26 in here all together. He discovers that 14 have dogs. So we have a group of people with dogs. 10 have cats. We got a group of people with cats. And 5 have fish, so we also have a group of people with fish. We have 3 different groups. Let me write this down. 14 had dogs, 10 had cats, and 5 had fish. Now, before I keep on reading, I want you to notice something. Do you notice now for the dog circle, there's 1, 2, 3, 4 different groups that have to add up to 14. If you look at the cat circle, there's 1, 2, 3, 4 different groups that have to add up to 10. And in the fish circle, there's 1, 2, 3, 4 different groups that have to add up to 5. And if you add up all of these things, plus the people not part of any of this, it has to add up to 26. Okay, so let's keep on going. Let me get out a different color here. 4 have dogs and cats. Now, this is very important to understand. This is where people make a common mistake. A lot of people will say 4 have dogs and cats, and they'll put a 4 right here, and that's not totally true, okay? Don't all the people in here, I went to the wrong, I'm sorry, I just was pointing at the wrong thing. I meant here. I want to erase that blue because I just misspoke. Let me go back here. Okay, start all over again. 4 have dogs and cats. I meant to say over here, okay? These people in here own dogs and cats. Now, you might say, well, wait a minute, Mr. Lemansky, these people here could own fish too. That's fine. But if I ask anybody in the room, who owns a dog and a cat, these people here are going to raise their hand also, along with these people. These 2 groups have to add up to 4. Let me get a different color. 3 have dogs and fish. Well, anybody in these 2 categories here would be dog and fish, so these 2 have to add up to 3. 1 has a cat and fish. Well, that means these 2 categories here are the cat and fish, because you can see these people could own cat or fish, so could these people. And then finally, no one has all 3 kinds. If no one has all 3 kinds, well, where are the only people on here that own all 3? Well, I think you can see that'd be in here. So I got to put a 0 here. It's kind of small, but I think you can see it. These people are the only people that could own all 3 at once. So no one has that. Well, how many patrons have none? Well, we'll answer the question if we fill everything out. So if no one owns all 3, well, now we can say, okay, 4 have dogs and cats. This plus that is 4. This must have been a 4. 3 have dogs and fish. Well, 0 plus that is 3. This must have been a 3. And 1 has a cat and fish. 0 plus this is 1. That must have been a 1. And now we can fill out everything. There's 14 in the dog circle. 4 plus 0 plus 3 is 7. 7 plus 7 gets me 14. 10 own cats. 4 plus 0 plus 1 is 5. 5 plus 5 gives me 10. And 3 plus 0 plus 1 is 4. 4 plus 1 is 5. That's got to be a 1. And now if I add all these up plus this, I got to get 26. Let's do that. 1 plus 1 plus 0 plus 3, this is 5 in here. 5 plus 5 here is 10. 10 plus the 4 is 14. And 14 plus the 7 is 21. And 21 plus blank is 26. This had to be a 5. Well, there's my correct answer. There were 5 people that own none of these kind of pets. Those are the ones that own the weird pets like the alligators or the snakes or horses or whatever. Okay, they're not owning the common dog, cat, fish. They have some other kinds of pets other than that. Okay, so I gave you specific examples on Venn diagrams. This video has been long enough. I'm going to stop it now. And when we come in tomorrow, you'll have an opportunity to practice Venn diagrams, sets, unions, and intersections.